Hello Bearcats! We're going to learn about combinations and compositions of functions. We're going to start with combinations. Let's take a look, and this is a bit of a review from last year. So if you see the notation f plus g of x, that would be the same as f of x plus g of x. If you see the difference, f minus g of x, it'd be like the function of f of x minus the function g of x. Now be careful about negatives or subtraction because you'll have to distribute a negative. For product, that's f times g of x. You would write it as f of x, and it could be times g of x. And you would multiply if you can, or you may have to, if you can simplify, you would. And then for a quotient, f over g of x, you would write it as f of x over g of x. And again, here you're going to have to make sure you have a domain restriction. So make sure you look for domain restrictions because you would have a zero. You can't have a zero in a denominator of a fraction. All right, let's take a look at an example. We're going to start with finding a quotient, of f of g over, f over g of x. But before we do that, I want us to notice the two functions that we've been given. They are both square roots, and we have to be very careful about domain restrictions when we get to square roots. Writing this out first is pretty easy. We're going to write f of x over g of x. All right, so that would be f of x would be the square root of x over the square root of, you know what, I want to switch that. Sorry about that. I want to do g of x over f of x. So I want you to have g over f of x. All right, so now that would equal g of x over f of x. And you would just write that out as the square root of 4 minus x squared over the square root of x. We're going to talk about simplifying that in a minute. But now we're going to focus on domain, what our domain would be. And we have a lot of restrictions going on here. We're going to take this piece by piece. First of all, you know, I love to use number lines to find these domains because the domain when you're dealing with two functions is the domain where they overlap. It's where they share a domain. So in this particular case, you know that your domain here could be from 0 to positive infinity because this could be a square root of 0 or any positive number. So that would be our domain. I'm going to go down here and use a number line. So it could be from 0 to positive infinity. So here's 0 to positive infinity out here, and this is negative infinity on this side. Now, we have a little issue because this particular function is going to be in a denominator. All of a sudden, 0 can't happen. You cannot have 0 because it would be a restriction of your denominator. So all of a sudden, this would have to be a soft bracket. So all of a sudden, you're going to write an open circle at 0. You cannot have 0 in the denominator. That's an overriding restriction. Now let's take at the restrictions we would have for this function. And we're going to have to think about this. You're going to have to use just some test points. What would make this 0? Let's think about this for a minute. What would make this 0? 2. Okay, so if I put a 2 here, and I plug a 2 in there, 2 squared would be 4, 4 minus 4. But what also do we know? If I make x negative 2, well, if I make x a negative 2 and I square it, it becomes a positive. And all of a sudden, you would have 4 minus 4 again. So all of the values either on the right and the left or all the values in the middle are going to be the domain for this particular function. So let's just test a point. What is something between 0 and 2, or negative 2 and 2 would be 0. If I plug a 0 in for x, that would be 0, and the square root of 4 would still be positive, and you could take that, it would be 2. So it's all the values between these 2 points that are true. Let's go ahead and put that on our number line below. And it could be equal at both. So these could be solid dots. So at negative 2 and positive 2, you could have all the points in between. But notice all of a sudden, this would not overlap. But right here, you would overlap. This part would overlap. So your domain is the overlapping part. And since we can't be equal to 0 because it's a denominator, you'll have a soft bracket here and you'll have a hard bracket here. And that will be your domain. So the first thing we're going to write over here is our domain would be from 0 to 2. And that would not be equal at 0, but anything greater to 0 up to 2. Now let's go ahead and talk about simplifying something. We really don't like square roots in denominators. So I'm going to show you how to clear that out real quick. And I'm extending a little bit right now. So 4 minus x squared over the square root of x. To get rid of a square root, you could multiply by the square root, because that would be a square root squared, and they would cancel each other out and just become x. But if you do that in a denominator, you would have to also do that in the numerator. And so all of a sudden you have 4 minus x squared, square root of 4 minus x squared, times x squared all over x. And we're going to stop there for right now, but we will extend this a little bit more about simplifying our numerator. The big thing here, the big takeaway here, is making sure you can find your domain based on all the restrictions that you would have in a problem like this. All right, let's move on to compositions. Compositions are written with that little, looks almost like a little degree symbol between them, and you read it as f of g of x, and you would rewrite it, because we rewrote a while ago, as f of g of x. And compositions are things where you're going to have to do this part first and solve it and then plug it into the f. And we're going to do that in just a minute. But again, we're going to have to be careful about some restrictions. So I want to go ahead and make sure we know our domain restrictions first. All right, so I'm just going to draw a number line again. I'm looking at this equation right now, x squared minus 9. X squared could be, or x could be any value. So our entire number line would be good. So I'll just do a little bitty squiggle there. So from negative infinity to positive infinity, we would be good. But now let's take a look at our second equation. Our second function, we already know the issue. We could have a 3, or we could have a negative 3. And let's take a look. Let's try 0. If we put a 0 in there, we would still have a positive, so it's everything between 3 and negative 3 that would be true. So now we're going to impose that on the other number line. So from negative 3 to 3, we would have an overlapping, and in this case, we would have equal at negative 3 and at 3, and that would be our domain. So right now, we're going to write our domain is between negative 3 and 3. All right, that was the first thing that we had to figure out, and it's the intersection of the two domains. So where they overlap on a number line is really helpful. Now let's go ahead and do our composition. So what we're going to say is we want g of x put into our f function. So we want all of this information substituted in for the x in the other function. Some people like to write this, g of x, and you could write it as f of, and then you could substitute in the g of x part. So that would be the 9 minus x squared. And then you're looking at your f function and realize I want that to go in for that x. Okay, and that would be helpful. And some people even rewrite it and go x squared minus 9 and realize, oh, I want this chunk of information to go in for this x. Whatever helps you. So I'm going to put a parenthesis, and I'm going to write the square root of 9 minus x squared, and then I'm going to square it minus 9. And now let's take a look at what happens. We have a square and a square root, so they would cancel. We would have 9 minus x squared minus 9. Our 9's would cancel, and we would be left with negative x squared. All right. Let's move on and talk about decomposing functions. We'll get a lot of practice on compositions in class. Decomposing functions. I've written down a little piece of information here that's important. This is an important process in calculus for you to be able to identify two functions that make up a given composite function. The hint is to look for an inner function and an outer function. We're going to take a look at this by example. Here is a function that's already been composed. So it's a composite function. There are two functions that made up this function. So our example is, what could we find as our first function? We're looking for an f of x function, and we're looking for a g of x function. So take the simple thing. Look, this is a transformation, this minus 2 part. So let's see if we had just the 1 over x squared. And this is really more of just being visually able to see some of this stuff. So I'm going to go 1 over x squared. And then I'm going to come over here. That would be my outer function, because this is my h function. I'm looking for something to make up the h function. The h of x function came from like f of g of x. Okay? So it came from something like that. Or you might write it, I always write it as f of g of x. Alright, so this would be maybe my outer function, and my inner function would just be this bottom part, x minus 2. So in other words, if I plugged x minus 2 in for this x, I would go back to this composed function. This is a little tricky. You're going to have to practice this, but you'll get better as you practice. This is new. I'm going to give you one more example, and then we're going to be done. So what if I gave you my h of x was equal to 3x minus 5 cubed? Well, take away all the transformations inside, and your base function, your outer function, we're going to call it f of x, could have been just x cubed. And then our inner function, our g of x, would have been the inside part here, which would be your, 3x minus 5. And let's see if that works. So if I wrote it as f of g of x, and that's how I'm going to find h of x, then g of x, so I would have f of 3x minus 5, and we know that that is supposed to be x cubed, because that's what f of x is, equal to, then I would take this chunk of information and plug it in here. So I would end up with 3x minus 5 cubed, which is what my h of x function is. So this checked out. All right, I know that seems a little complicated, and it should at this point, because you haven't practiced it any, but we will practice in class. All right, go Bearcats!